Okay, so today's notebook entry is on mixed factoring, which is basically reviewing everything we've done in this chapter. It's just all mixed together, so we've got to be able to identify what type of factoring to apply and then follow through with that strategy. So this work that you do today is important because it is going to be starting to get you ready for your test coming up here. So even classes test will be on Tuesday, April 30th. And odd classes, the test is on Wednesday, May 1st. So again, today's work that we do is more or less the beginning of the review process to get ready for that test. So let's jump right in here. So on the flowchart side, we're going to start with that. And this flowchart is just a way for us to help visualize the thought process that we need to be able to do and memorize, right? So this thought process is what we have to have memorized for that test, knowing what to look for first and then how to determine each of the types of factoring to then look for. So on your flowchart, again, pause the video, rewind, rewatch when needed, but on your flowchart, fill out the examples, fill out the completed examples as we go, and make sure you're doing your best to do what you can. So first thing, top of this flowchart is greatest common factor. So that is always what we look for first. So in that polynomial we have, there is a GCF of 3x squared, and the remaining factor then is x minus 4x plus 3x to the third. Okay, so that polynomial, right? So this expression is the answer, but if I look at this trinomial, that trinomial, yes, it's a trinomial, but it's not a quadratic expression, right? Not in this form. So I would eventually, if I was going to try to factor completely, I would not factor this any further because it's not in that quadratic form. Okay. So the next thing I look for is difference of squares, right? So if there are two terms, I look for difference of squares, and that right away, if it's difference of squares, we've got two parentheses, 1 plus 1 minus, and then we take the square root of each of those two terms, right? Or those are both perfect squares. So remember, perfect squares right? So the numbers are perfect squares, and then the exponent is even. So those are all perfect squares. So in this case, my two factors are going to be 5x plus 6 and 5x minus 6 are the two binomials that create that expression. So if I look and then I don't see two terms, but I see three terms, that's what I'm looking for, that quadratic expression form. Right? So that format with the trinomial, this would be a good place to write down that general form. That's the pattern I'm looking for to know when to factor that trinomial. So for that first example, x squared plus 2x minus 8, that is in that trinomial, that quadratic form. And so we can break that into our two parentheses, and then in this case, it's going to be x plus 4 and x minus 2 would be the two factors. For that second example, even though we're in the three-term category, there is a GCF first. So that GCF of 4, we would take that out, and then again, notice the remaining trinomial. Right? That's what I was saying earlier. In this case, this follows the quadratic expression pattern. So I would then go ahead and factor that one more time, and I would get n minus 2 and not n minus 3. Sorry, that should be an n minus 1. So n minus 2 and n minus 1 are those two binomials. So this would be the final answer. And then if there's not three terms, then there's four terms. And if there's four terms, then we factor by grouping. And again, there can be a GCF to begin with, but if we've already checked for it and there's four terms, then we follow through with grouping, right? So we group them into two groups, and then we factor out the GCF from each group. And then notice again, we have that matching factor. 3p plus 1, we bring that down and then bring down the remaining GCFs to create that second factor. Okay. So that's what we're going to practice here on the back side, is just going through that thought process. So if you go ahead and flip your paper over here, we're going to take a look at a few of these together. Again, I'm going to talk through these pretty quick. You can always pause, rewind the video, go back through the thought process. But these, again, are just going through more the process, the thought process that you need to memorize for that test. Okay, so we have to memorize, what are we looking for, right? Did you check for GCF? And then look at how many terms there are and know what type of factoring and what that process of factoring looks like. Okay, so for this first one, we have 3 terms. I can see there's no GCF, but there are 3 terms. And if there are 3 terms, I would look for guessing and checking that trinomial. Okay, so in this case, I can set up my 2 binomials, right? Pretty quick. I know that it's n and n, and then one positive, one negative, because they multiply to a positive. Right, so the C value is negative. They multiply to a negative. The C value is negative, but they combine to a negative. Okay, so if C is negative, then that means you have to have one negative, one positive. And then in this case, there'd be a -8 and a +4. So those two things multiply to -32, and they add up to -4. And then that's it. That's my answer. Okay, so on problem 2, we have 4 terms, but I want to look for a GCF first. So in this case, I notice that, yes, they are all divisible by 7. So there is a GCF of 7. So we're going to go ahead and take that out right off the bat. And the expression we're left with has 4 terms. And if there's 4 terms, then we factor by grouping. So if I group those 4 terms into 2 groups, and then look at the GCF for each group, let's see, -1 for that second group is the GCF. So I have p squared, 4p plus 3, and then -1, and 4p plus 3. So then when I put together my final answer, I'm going to bring down the GCF, right? So make sure we've got the GCF down there in that final answer, and then the matching factor along with the 2 GCFs. All right, so on this one, problem number 3, there are 2 terms, but again, I want to look for a GCF first, and I can see, yes, there is going to be something we can divide by. We can, looks like, divide them both by 4, and they both have a common variable. So if we take out 4r squared, we're going to be left with 2r minus 3. Okay? Now, there are 2 terms left in that remaining factor. But those 2 terms are not a difference of squares. Okay, so there's nothing else we can do here. It was just a GCF question. All right, number 4. So again, GCF. For this one, no. And number of terms, there are 2 terms. And this time it does look like they are difference of squares, right? 16 is a perfect square, b squared, it's an even exponent, and 25 is a perfect square, right? So in this case, we can split that up with our difference of squares factoring pattern. And that is 1 plus, 1 minus, right? So a positive factor and a negative factor, and then we have 4b in the first part and a 5 in the second part. Okay. And then at this point, that's it. That's as far as we can go. All right, number 5. Why don't you pause the video and take a moment, see if you can work through this one. All right, so first things first, again, GCF, yes. I can tell we have to factor out a GCF of 2. So if we take out that GCF of 2, we're left with v squared plus 4v minus 5. So again, that is then 3 terms, which is guessing and checking. And again, if you remember, we could set up an area model to factor. So we got v squared, -5, and then remember these 2 spots have to combine to 4v. Again, we know V and V go on the outside, and then we have to have things that multiply to -5, which is 1 and 5, but one of them has to be negative. And so in this case, again, the result of adding those two together has to be +4. So I know that +5 and -1 adds up to +4. And if I check that by filling in those spots, 5V minus 1V, yes, does equal 4V. So remember my answer here, my final answer for when I use the area model is the two outside lengths and widths. So V minus 1 and V plus 5 are part of my final answer along with my GCF. All right, so remember if you were doing just the binomial method, you got your two binomials and then you got to figure out what multiplies to -5 and adds up to +4, just like we talked through there. Okay, so there's the final answer. All right, number 6. So first of all, again, we need to work on making sure we're memorizing the thought process. Knowing, always check for GCF first, in which case, no, there's not one here. Recognizing there's 4 terms, so that means we have to memorize 4 terms as grouping. So we're going to group, we're going to take the GCF out of the first group, GCF out of the second group is going to have to be -2 to get those signs to switch to match that first parenthesis. And then my matching parenthesis is 2V minus 1, and then my remaining GCFs come together as that second factor. And then that's it for that one. All right, so for this one, let's take a look here. GCF, yeah, I know at least 5 goes into both of those just because both numbers end in 0 or 5. So definitely GCF, and I believe 5 is the largest thing. So both of these we can take out of 5. And if you take out of 5, you're going to end up with 4k to the 4th minus 25. So the remaining factor, what's left on the inside there, has 2 terms. And so we're checking for that difference of squares. And as far as I can tell, right, 4 is a perfect square, 25 is a perfect square, and the exponent, 4, is even. So we can divide that in half. So yes, this is a difference of squares, because again, another key part of that is the difference. It's subtraction. So this is a difference of squares pattern. So we can split that up into 2k squared plus 5 and 2k squared minus 5. And then just don't forget the GCF. Make sure we have that that we took out at the start. And last one here, problem number 8. Again, checking for a GCF first. I can see right away all of the terms have common variables at least. So I'm guessing they'll have a common number as well. But at the very least, yes, GCF. So if I take a look, 4, 12, and 16, 4 is the largest number that goes into all of those. And then I'm looking for, again, the smallest exponent for common variables. So right here, x is what I'm going to include. And for the y's, it's just a y. So 4xy is the GCF. So take a moment and try factoring and bringing down the remaining factor before you watch the rest of this. So this is a good one just to double check your work, right? So your GCF is 4xy, and then when you divide that to each of those terms, you're left with xy squared minus 3y plus 16x to the third. Okay. So at this time, that is the end of the notebook entry. You will then be working on a little bit of partner practice, and which you can work on in your table groups, and then moving on to homework number 24. Homework number 24 is a good example of what your test is going to be like. It's just going to say factor completely, and you need to factor completely. So that's a big part of that test coming up here, is just knowing and having the thought process memorized of how to do each of these and then following through.